Okay guys, so this is the continuation of the paired samples t-test lecture. So what I did was, just to make things easier for us, is I transferred the values that we were going to need over from the previous page. So we have our mean of the difference. All right, so mean of the different, or the mean of the difference between the mean of the difference between scores, which was 0.7. The standard deviation of the difference is 0.79. The standard error of the mean for the difference was 0.35, and our t-critical value was 2.132. So we have everything that we need now to calculate our t obtained, and that is, so t obtained is equal to the mean of the difference divided by the standard error of the mean of the difference, right? And so that's going to be 0.7 divided by 0.35, and this is actually fairly simple math. It's going to give us a value of 2.0. Okay, so now we have to make a decision, right? So as we were doing all along, we have to compare our t obtained to our t critical value, and if we do the same thing we've been doing all along, right? If 2.132 is our critical value in the this is a t distribution, right? And this is our cutoff. This side is the rejection region, right? And this side is the acceptance region. And again, when we're talking about rejection or acceptance, we're talking about rejecting or accepting the null. And then we place our obtained t within that distribution. It's falling squarely in the acceptance region. So we are failing to reject the null hypothesis once again, and we're accepting the null hypothesis. So we have to, as in the past, make a statement so we can report our results. And what that should look like is something along the lines of results showed that there is no difference between freshmen and sophomore GPAs except the null. And our t, again, we report our degrees of freedom as 4 equals 2.0, and our p value is greater than 0.05. Now, what we have sort of discovered at least a couple of times in the past was that although we failed to reject the null hypothesis, we ended up getting a fairly large effect size. And so, as I mentioned earlier, it is important to calculate effect sizes, especially when you have a small sample such as this one, in order to see whether the effect is meaningful, even if it's not statistically significant. Now, when we're reporting research, when you read research studies, you're not going to see people necessarily reporting non-significant results and effect sizes, but in this case, what I've talked to you about earlier was that because the t distribution relies heavily on the size of the sample, having a small sample makes it much more difficult to reject the null hypothesis. Okay, so in order to calculate our Cohen's d, right, that's going to be equal to the mean of the difference divided by the standard deviation of the difference, which is going to give us 0.7 divided by 0.79, and that is going to give us an effect size of 0.089. Oh, and I'm sorry, it should be the absolute value of this. Do not let me forget that, right? Because there's no such thing as a negative effect size. So what's important about this, again, is that although we fail to reject the null hypothesis because our obtained t does not fall within the rejection region, we're noting that we have a fairly large difference average difference between the scores, equivalent to about 9/10 of a standard deviation. Right? So that can be a pretty substantially large. And based on our criteria, we would call that a large effect. And as with our independent samples t-test example that we did the other day, it's suggesting that perhaps, no guarantee here, but perhaps we've made a type 1 error. No, I'm sorry, type 2 error. Goodness. And I may have made the same mistake on the previous video. It's a type 2 error, right? We failed to reject the null hypothesis when it was false. It's a false negative. That would be a type 2 error. My apologies. Okay, so it's very possible that in this case we made a type 2 error. Okay, and that's it. And I will see you guys in class.